of the Always Believe House. And today we're going to have a rocking and rolling lesson. Hopefully you did. The PSAT was yesterday, so we're going to pick up. We are not going to do equations of lines. So on Monday we did parallel lines to a given line. On Tuesday we did perpendicular lines. You had to flip the slope and switch the sign. Today we're going to talk about discrete and continuous functions. So you may not know yet about what is a discrete continuous function. You're about to find out, and it is going to be F-U-N, fun, fun, fun. Oh. So let's get rocking and rolling. Oh, let me record this, or I will be doing all of this for nothing, like I've done before. We are recording and a magical whiteboard appears. Okay, so today it's the same thing as the domain and range we've done before today, but I've tweaked this. You're going to learn the difference between what's discrete and what's continuous. So let's go through this. The domain is the possible x values. The range is the possible y values. And remember, whatever your x is going to be your independent variable. And whatever your y is going to be your dependent variable. And from the star reviews, you're doing these every week, aren't you? You're writing down the domain and the range of all these functions, okay? Now let's keep going. The domain is read from left to right. On the x are from the smallest to the largest. The range is read from the bottom to the top, or from the smallest to the largest. When the domain and range, when you write this is not spelled right. When you write the domain and range from least to greatest values, you will always use less than symbols. Okay, so remember, we put less than symbols, put x in for the domain, put y in for the range. But today, you're going to learn about what a discrete function is and what a continuous function is. A discrete function is made up of whole number or integer values, like selling tickets or doing car washes. You can't wash half a car, okay? If you're selling tickets, you can't sell half a ticket, okay? If you're selling apple pies, you're not going to sell half an apple pie. You're sell the whole thing, right? So things that you are doing that require whole number integrals, okay, or whole number intervals, that is a discrete function. You will not connect those with the straight line because it does not include the decimal values. So when we write the domain and range of that, we're going to write down the actual numbers that are in the domain and range. A continuous function involves all real numbers within a range of values, like the amount of fuel in a tank as the engine runs. If the fuel is constantly going down. Or what if you're filling a swimming pool up? The water is constantly going up. Or if you're in a taxi cab and you're paying by the minute, the cost is constantly going up, okay? You can be charged by the penny on that because the time is continuous. You're constantly paying for the time. So let's go through these, and you're going to learn the difference between the two. Now then, on the star reviews, you're going to write all of these down as continuous so you can get used to writing the domain and range. But on this one right here, okay, Lucy Claire has $10 and spends $2 each day for lunch. Notice I've made this up. Okay, I graphed it for you. At 0 days, she would spend $2, right? Or she would have $10, wouldn't she? At 1 day, 2, 3, 4, and then 5. At 1 day, she would have $8, right? This would be 1, 8, and then 2, 6, and then 3, 4, and then 4, 2. And what happens on the 5th day? She would have $0, wouldn't she? Now then, she would never ever have like $9.65. Her money would go down by increments of 2. This would be a discrete function. So in this problem, the domain would equal to the number of days, and the range would be the money. Okay? This would be a discrete function. When writing the domain and range in a discrete function, write the values in a set of braces, which looks like this. Where it's a set of numbers. Whenever you write a set of numbers, you use a brace. If you want me to make this bigger, it looks like this, right? So whenever you write domain and range in a discrete function, you'll put your answers in braces. Okay? Write the numbers from least to greatest and write down repeating values only once. So if there's 2 8s in the range, you'll only write one of them. So you're going to write down the numbers from least to greatest, and you'll write down each number once. So write down the order of pairs represented: 0, 10, 1, 8, 2, 6, 3, 4, 4, 2, and 5, 0. Let's add the 5, 0 in there. I forgot to put that in there. So we start at 0, 10, and we work down to 5, 0. An input of 5 would be 0. That would be your x-intercept, or 0, the function with it. The domain would be the set of x values. So the domain would be equal to 0, 1, 2, 3, 4, and it would be 5. Put a brace. The range would be equal to the set of y values. Okay, so for the range, let's put capital R equals, I forgot to fill this in, put a brace, and we write the range from the least to the greatest. So the least, the range is going to be a 0, and then it's going to 2, 4, 6, 8, and 10. The range is the money, the x is the days in it. Okay, so our domain is going to go from 0 days to 5 days, but you can't get half a day in this, can you? Because you're only spending lunch once, aren't you? The range, or the independent variable of this would be the days, and the dependent variable would be the dollars, wouldn't it? Okay, and this is how you would write down the domain and range. So if it's a discrete function, you will not put the inequalities. You'll write down the actual ordered pairs. The x's are your domain, the ranges are your y's. Let's keep going. Oh. Okay, number 1. Jiminy John only has 16 ounces of fuel in his weeder. Oh. Every minute he uses 2 ounces of fuel. Write a function if, it should be if, not if the ounces is a function of the minutes. Okay, so underline function of, the ounces will be our y and the minutes will be our x, won't it? So the ounces are going to be our dependent variable and the minutes will be our independent variable. Okay, now then what's going to happen to the fuel in this? It's not going to go up, it's going to go down, and the weed eater is running, so this will be a continuous function, won't it? Okay, so we're going to have negative 2x plus 16, right? This is my growing number, this is my starting number in it. The slope of the line is negative 2, and it represents 2. Y is what? Ounces per x is minutes, right? So this is my y, this is my x. Those are the 2 words that are on the y and x axis, aren't they? This is also my dependent variable. This is my independent variable, right? Now then, let's go through this. What would the y? This is just like your star review problems, isn't it? Exactly like that star review on the back page at the top. You're going to do that every week of the year. Okay, what would the y-intercept of this graph be? It would be 16. And when would we run out of fuel? How many 2's are in 16? There's 8 of them, aren't there? So let's put an 8 right here. This would be it. Put the 0, and this is going to be our domain and range. We connected the dots because it's a continuous function. The fuel is constantly being drained from the tank. Okay, so what would the y-intercept of the graph be? 16. This is the initial amount, right? Or the starting amount. That's your starting number, right? Starting amount of fuel, or starting amount of ounces, right? What would the x-intercept be? It would be 8. 8 minutes equals what? 0 ounces, right? At 8 minutes, you would have no more fuel. This is a continuous function, so we're going to identify the domain and range. The domain goes from 0 to 8. You put an x in the middle and less than or equals, right? The range goes from 0 to 16. You put a y in the middle and you put less than or equals. Pretty simple stuff. I'm going to do one that's a discrete function, and I'm going to let you finish up on your own. Okay, number 4 is a discrete function. Okay, Emma Sue has to sell 6 raffle tickets. Each ticket costs $10. Write this relation if the total amount of money is a function of the number of tickets sold. Let's identify our y and our x. The total amount of money is our y, and the number of tickets is x in it. So the y-axis will be money, the x-axis will be tickets. Ho, 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 ho. So how much money are we going to sell? Okay, now that in this problem, 10 is not the starting number, is it? She starts off with $0, doesn't she? And then she sells, her growing number is what? $10, right? And she's got to sell 6 tickets. So we're going to start at 0 and the graph's going to go up, right? So the equation would be 6x plus 0, or just y equals 6x. This would have direct variation, and hopefully remember, 6 would be the constant of variation. If you multiply 6 times any x, that's going to be how much money she has. So the slope of the line is 6, and it represents $6 per ticket. And remember, the dollars is your y, the ticket is your x, this is your dependent variable, this is your independent variable, right? That slope contains all that information. Now then, let's graph this. We're going to start off at 0, 0, and then 1 ticket would be $6, and I'm just going to put a dot. 2 tickets would be 12, 3 tickets would be 18, 4 would be 24, 5, 36, or 5 would be 30, and 6, 36, right? So if I wanted to, 0, 0, 1, 6, 2, 12, 3, 18, 4, 24, 5, 30, and 6, 36. Those would be my ordered pairs, right? I could make a T-chart too, couldn't I? A T-chart might be a little bit easier. The y-intercept of this graph would be 0, and it would represent the initial amount of money, or the starting amount, right? She has $0 when she starts. Would this graph have an x-intercept? Yes, it would. It would be 0 because that's the start. That it would start at the origin, right? Why? It has direct variation, right? If the line has direct variation, it's going to have 0, 0 as an ordered pair, right? So it does have an x-intercept, but the cost is going to keep going up. This is a discrete function. Okay, so we're going to write down the ordered pairs again. 0, 0, 1, 6, 2, 12, 3, 18, 4, 24, 5, 30, and we need one more, 6, 36. Now then, the domain, I already have the braces down, but you're going to put into the braces smallest to biggest. It's going to be 0, 1, 2, 3, 4, 5, and 6, would it? So the domain would not be 0 to 6 because we're not going to do half of the ticket, are we? These are the tickets, right? And then the y, the range, would be our money. So the money would be 0, and it's going to be multiples of 6 in it. 6, 12, 18, 24, 30, and 36. She's never going to have like $33.20, is she? She's only going to have multiples of 6 in her bag. So this would be the money. So that's your domain and range. That is a discrete function, okay? So remember, in a discrete function, you're not going to write down inequalities. You're going to actually write down the numbers. In a continuous function, you would write down the inequalities. What a great day. Let me get this meeting ended. I hope you have a wonderful, wonderful day. You've learned about discrete and continuous functions. Discrete functions only use whole number values. Continuous functions is what we've been doing all year, where you use the inequalities. Have a wonderful, wonderful day. Remember, you are amazing. You are created to do wonderful things, and you are awesome.